This is also just theory, something we have to know. So our strongest acids are our HCl, our H2SO4, and our HNO3. There are other strong acids, but these are the most common ones that we use in our syllabus, which means that any other acids that aren't these for the most part, and if they haven't pointed to the fact that it is a weak acid, are most likely weak acids. But then our strong bases are things ending in OH for the most part, and things in group 1. So we have an LiOH, an NaOH, and our KOH. Those are the most common ones. So we're looking in group 1 on our periodic table. We have NaOH, KOH, and LiOH. These are the common strong bases we work with, and then weak bases are basically anything else. So these are our strong bases, and then most of the other bases are usually weak then. And then something else to keep in mind for a weak acid, they kind of look like organic molecules. Like acetic acid, don't know it off the top of my head, but it's CH3CO something. And it looks like an organic molecule, and it is a weak acid. So what I've found is that these are just the most common ones they use for these strong acids and the strong bases, which means that if it isn't one of these guys for an acid, it is most likely weak. And if it isn't one of these guys for a base, then it is most likely weak. So then with that information, once again, they said explain why phenolphthalein would be a suitable indicator for this reaction. It has a strong base over here, this NaOH, and then it doesn't have one of these strong acids over there. Okay, it has this guy, kind of looks like an organic molecule, H2C2O4, and that is our weak acid, which means we can just go ahead and say that NaOH is a strong base and oxalic acid is a weak acid. And therefore, like we were talking about with the midpoint method that we were using, we have a strong base and a weak acid, which means our midpoint is somewhere above 7, which means our pH is greater than 7 because of the midpoint landing there based on how these two guys react. And there being more OHs left at the end than H3O pluses. Because what happens when these two guys combine with each other is that the H3O pluses, the little amount that it has for this weak acid, and the OH minuses, the large amount that the base has, combine together to break down to form water. But then at some stage, and we'll use an army analogy just now in the next question, is that these guys combine, form water, but then we eventually run out of H3O pluses because there's not enough H3O pluses because it is a weak acid, which means at the end, when we measure our pH, we're left with a lot more OHs, and that gives us a pH that is greater than 7 over here because we have no more H3O pluses, we only have OH minuses that have not been neutralized to form water again.